Okay, good morning. Welcome to
SuperMath177.
SuperMath177. So this problem was actually the problem I did with your brother this morning because he's studying quadrilaterals. And I asked you about it, and we had a little bit of a hard time remembering how this works. So we spent the morning kind of reviewing it. So this says I've got, what kind of shape here?
A trapezoid.
Trapezoid. The area is 120. Find the length of the second base. So what do you need?
You need,
What's this problem about?
it's the area of a trapezoid.
Okay, what do you need to do to solve it?
You need to know the area of a trapezoid formula.
Sure. So what do you need to do to solve? What are you looking for in this problem?
Well, I'm looking for the second base.
So this problem is all about this base.
Yes.
About this base.
Yes.
Is this problem going to give you any trouble?
No.
It's all about this base.
Ah.
About this base. No trouble.
So, I'll call this B.
Alright.
So the area of a trapezoid is the height, 6 times sum of the bases, B plus 10, over 2. B plus 30. And then this is equal to 120.
Okay, the second base is 30. I would recommend you remember the old rule, simplify before you multiply. 3 times b plus 10 equals 120.
Yeah,
What
so
can
you
you
could
do?
divide by 3.
So
B plus 10 is 40, so B is 30.
So if you see what you did is you multiplied out and then divided at the end, but you can just divide right from the beginning and you have simpler numbers to work with. But what I'm more interested in, other than jokes about trapezoid problems and actually finding this out, is I would like you to explain, I don't want you to go all the way through the calculation, but I would like you to explain how you re-derived the formula for the area of the trapezoid this morning, because it was actually pretty interesting to watch. In fact, I'll erase the whole thing so you have all the board here.
So
you couldn't remember the formula, and mean old me would not tell you the formula.
So you can look at a trapezoid, but we don't know much about a trapezoid. So we can flip the trapezoid upside down and rotate it.
No. That is not how you derived the formula for the trapezoid area this morning. I showed you that after you did it, but you did not. That is not how you did it.
So the way I did it was I pretended it was a triangle. And this is, I call this B1 and B2. This is height 1 and height 2.
Okay. So what's the area of your trapezoid?
So the area, should I write this out?
Yes.
Alright. It's the area of the of this big triangle, which is 1/2 base B1 times the height H1 plus H2 minus 1/2 B2 H2.
Okay. So you wrote down, you said, let's extend these other sides up, or the legs of the trapezoid up, and form a triangle. I know the area of that triangle. Now that is not at all a bad strategy. You take a problem that you don't know, the area of a trapezoid, reduce it to a problem that you do know, the area of a triangle. So that's a very good first step. And then what did you need to do next?
Well, first you just have to factor out half.
Well, fine. You can simplify and all that stuff, but what's the problem with your formula here?
That I've got a lot of variables.
That's true.
So I noticed that we had similar triangles.
Well, but it's not you haven't identified the problem with that formula yet. What's the problem with your formula? when you're trying to find the area of your trapezoid?
Well, H2 really isn't going to come into play at all, though.
Okay, right. The area you're going to get to is 1/2 B1 plus B2 times H1. This also has a lot of variables.
Yeah.
So the problem isn't that it has a lot of variables because your formula itself has a lot of variables. The problem is what?
Is that it's H2.
H2 isn't in a trapezoid. You only have the one height. So the problem is what? What do you need to do next?
I need to figure out what H2 is in terms of the rest of the variables.
Right. We got to get rid of H2 because it's not part of the trapezoid. And how did you do that?
Finding similar triangles.
Okay.
This triangle and this triangle. And then we set up a ratio. It's H2 to H2 plus H1 is B2 to B1.
Okay, so we had similar triangles and we set up a ratio. And then an entire board full of algebra
Yeah.
to eliminate H2. And we reduce this to a that complicated looking formula, by miracle,
Yeah, there's some good canceling.
reduces to a very
that
simple
happened.
formula. So it was good. It was a good derivation. It was a good derivation, and hopefully going through that whole process and deriving that 1/2 base 1 plus base 2 times the height helps you remember it next time. All right, good work this morning, huh?